Hi, my name is Mr. D, and today I want to take a look at converting from fraction to decimal form. So we have expressed the following fraction as a decimal, and we want to transform the fraction 3 over 16 into a decimal. Now the first thing that you need to be able to do with these problems is set this up as a division problem, and you need to set it up correctly. When you look at this, setting up the division problem, there's one thing we really need to be careful of. It's tempting to want to put the 16 under the division sign because typically we're used to seeing the bigger number under the division sign, but in this case the number under the division sign is going to be smaller than the divisor on the outside. So the dividend is going to be smaller than the divisor on the outside. So we're putting the 3 in the numerator. This is going under the division sign, and the 16 is going to be on the outside. So remember, just the hint, the denominator is outside, okay, and the 3 is inside. Just make sure you remember that, because if you set this up incorrectly, you are automatically going to get this wrong, right? From the beginning. So once we have this set up, we need to ask ourselves, remember, when we're doing division, we ask ourselves, how many times does 16 go into 3? Or can 3 be divided by 16? Well, notice if we look at the times tables for 16, 16 times 0 is 0, 16 times 1 is 16. So notice our goal is to get as close as possible to 3, but the only way to do that is if we use 16 times 0, because if we do 16 times 1, we go too far. So the first number we're writing up here as our quotient is 0, but this is where the decimal comes in. Whenever your answer is 0, you immediately throw your decimal right after the 0. And remember, you're going to have a decimal if your fraction has a numerator that is less than your denominator. So automatically that's where your head should be headed, that you should have 0 point something when your numerator is smaller than your denominator. But once you get to this step and you have your decimal, the strategy or the technique is to keep adding zeros onto the problem. If you want to put all the zeros at once, you can, or you could keep adding them as you need them when you have remainders, as we're going to see in a moment. So now we can ask ourselves, 16 did not go into 3, but can 16 go into 30? 16 will go into 30 exactly once, because if we look at 16 times 2, this would be 32, and we would go too far, so we need to write a 1 here. Now we have 1 times 16 is 16. We subtract to find our remainder, and we get 14. If you just want to see the steps real quick, we would borrow, since we have a 0, turn this into 2. Now we have 10 minus 6 is 4, 2 minus 1 is 1. But as you start to get better at this, you'll do it mentally. But notice we have a remainder, so that tells us we need to keep going. With decimals, when we're converting to decimals, whenever you have a remainder, you want to keep going unless they tell you to stop at a specific place. So to keep going, we just keep adding zeros. And now we can carry this 0 down, and we're doing 140 divided by 16. So when we get to this step, an estimation strategy you could use, I like to think of tens whenever I'm using division. What I mean by that is, since we're dividing by 16, 16 times 10 would bring us to 160, which would bring us too far. We have to be at 140. So this tells us that we're better off trying 16 times 8, and if you multiply this on the side or check it out, you should get 128 here like this. So we're going to write our 8 up top, and now we have 8 times 16 is 128. So notice at this step, we could borrow, we have 3, we're going to put our 1 here, 10 minus 8 is 2, 3 minus 2 is 1, we have a remainder of 12. But remember, once we have a remainder, if this number is not a 0, we have to keep going. And how do we keep going? We add another 0, and we drag it down. So now we're doing 120 divided by 16. But this is an example of how the work you do on the side of the page can help you. If you did 16 times 8 equals 128 on the side, you know that that would send you too far. Like, we can't write another 8 because it would send us past 120. So we could try the next number back. We could do 16 times 7. And if you want to do the long multiplication on the side, you can. Or you could just subtract 16 from 128, and you should get 112. So if you multiply 16 times 7 on the side, you'll get 112. Or you could just subtract 16 from this number. So then that tells us that we have to write a 7 here. That's as close as possible as we could get to 120 when we're multiplying by 16. So then we do 7 times 16 is 112. We're subtracting 112. When we subtract these numbers, we should get 8. If you want to see the borrowing steps, we borrow from here. We write the 1 here. 10 minus 2 is 8. 1 minus 1. 1 minus 1 cancels out, so we're just left with a remainder of 8. So notice we still have a non-zero remainder, so we have to keep going. We throw on one more 0. And now we're doing 80 divided by 16. But conveniently enough, 80 is evenly divisible by 16. 16 will go in perfectly. It will go in 5 times. Okay, we could even check on the side. 16 times 5. 5 times 6 is 30. Carry the 3. 5 times 1 is 5. Plus 3 is 8. So notice how it checks off. And now we can just close this out. 5 times 16 is 80. So we subtract the 80 and notice we have our 0 remainder that we needed. So this would be our final answer here up top. If we want to write it formally on the side, we could say that 3 over 16 equals 0.1875. Here like this. Or this is 1,875 10,000ths, if we were to say it properly. Okay, well this is going to conclude this video on converting from fraction to decimal form. Thank you all for watching, and I hope that this was helpful.